Hello all. In this session, I will be discussing about cylindrical and spherical polar coordinate systems and how to calculate gradient of scalar field, divergence of vector field, curl of vector field and Laplacian of scalar field in cylindrical and spherical systems. Cylindrical polar coordinate system. Any point P in cylindrical coordinate system can be specified as r, theta and z, where r can take the values from 0 to infinity, theta can take from 0 to 2 pi, that is the angle, and z can take the values from minus infinity to infinity. The relation between Cartesian coordinates xyz and cylindrical coordinates r, theta, z are x is equal to r cos theta, y is equal to r sin theta and z is equal to z. From these three relations, we can find the values of r, theta, z in terms of x, y, z. These results are r is equal to square root of x square y plus y square, theta is equal to tan inverse y by x and z is equal to z. Er, E theta and Ez. These are the unit vectors at the point in the direction of the tangent to the curves. Since the cylindrical polar coordinate system is an orthogonal system, therefore their dot products between Er, E theta, Ez and Ez, Er are 0. In cylindrical system, vector differential operator is defined as del is equal to dou by dou r Er plus 1 by r dou by dou theta E theta plus dou by dou z Ez. With this vector differential operator, the gradient of scalar point function psi of r theta z can be calculated by this formula. If vector f is a vector field f1 Er plus f2 E theta plus f3 Ez, then divergence of f can be calculated by this and curl of the vector point function f can be calculated by this formula. And Laplacian of scalar field, that is del square psi, can be calculated by dou square psi by dou r square plus 1 by r dou psi by dou r plus 1 upon r square dou square psi by dou theta square plus dou square psi by dou z square. Let us take problems. Compute gradient and Laplacian of the scalar field psi of r theta is equal to r plus z cos theta in the cylindrical polar coordinate systems r, theta, z. We know that gradient of the scalar field psi can be calculated by this formula. In this formula, if we substitute the values of dou psi by dou r, derivative of psi with respect to theta and derivative of psi with respect to z, when psi is given r plus z cos theta, then we get Er minus 1 upon r z sin theta E theta plus cos theta Ez, that is the gradient of given psi. When we will calculate the derivative of psi with respect to r, second order derivative of psi with respect to r and theta and z, and substitute in this formula, of Laplacian of psi, then we get 1 upon r minus 1 upon r square z cos theta. It is Laplacian of given psi. Let us take next problem. Compute divergence and curl of the vector field A is equal to sin theta er plus cos theta e theta plus rz ez, where sin theta, cos theta and rz are the components of vector A. We know that divergence of A is equal to this. In this formula, when we substitute the components of the vector A and differentiate these parts with respect to r, theta and z, then we get, after simplification, r. That is the divergence of the vector field A. If we substitute the components of the vector A in the curl formula and determine this determinant, then we get minus z e theta. That is the curl of the given vector A. Spherical polar coordinate system. In a spherical system, any point P can be represented as r, theta and phi. Here theta and phi measures the angles. The relation between the Cartesian coordinates x, y, z and spherical coordinates r, theta, phi are x is equal to r sin theta cos phi, y is equal to r sin theta sin phi and z is equal to r cos theta. From these three results, we can find the values of r, theta, phi in terms of the Cartesian coordinates x, y, z. These results are r is equal to square root of x square plus y square plus z square. Theta is equal to tan inverse square root of x square plus y square divided by z. And phi is equal to tan inverse y by x. In the system, we take er, e theta, e phi as unit vectors along the coordinate axis. Spherical polar coordinate system is also an orthogonal system. Therefore, er dot e theta and e theta dot e phi and e phi dot er are 0. In a spherical coordinate system, vector differential operator is defined as dou phi by dou r er plus 1 upon r dou by dou theta e theta plus 1 by r sin theta dou by dou phi e phi. Gradient of scalar point function psi of r theta phi is given as dou psi by dou r er plus 1 upon r dou psi by dou theta e theta plus 1 upon r sin theta dou psi by dou phi e phi. If vector f is f1 er plus f2 e theta plus f3 e phi, where f1, f2, f3 are components of vector f and these are the functions of r theta phi, then divergence of f and curl of f can be calculated by these formulas, and Laplacian of the scalar field psi of r theta phi can be calculated by this formula. Dou square psi by dou r square plus 2 by r dou psi by dou r plus 1 upon r square dou square psi by dou theta square plus cot theta by r square dou psi by dou theta plus 1 upon r square sin square theta dou square psi by dou phi square. Let us take one example. Determine the curl and divergence of the vector field f is equal to 2 cos theta by r square er plus sin theta by r e theta in spherical coordinates r theta and phi. In this vector field, 2 cos theta by r cube, sin theta by r and 0 are the components of vector field f. Substituting these values in the curl formula in this determinant and solving this determinant, we find 2 sin theta by r power 4 e phi. That is the curl of the given vector field f. Substituting f1, f2, f3 in the divergence formula and calculating the derivatives of these functions, we get the divergence of the given vector field, that is 1 upon r square sin theta multiplied by minus sin 2 theta by r square plus sin 2 theta. Thank you.